In this video we want to look at advanced features in terms of surface cladding in Para3D, and we first want to look at these smoothing functions in my two-dimensional array. We afterwards want to look at the spacing options in Para3D surface cladding, and at the end of the day, at this really nice surface optimization tools in Para3D. Okay, as an example, I just used this kind of scene, and what's really obvious, we are common and used to this, that you can just exchange these kind of objects, and I can also choose these torus node, and I just go into auto update. This looks disappointing, but we already know what we have to do. We can, for example, just say I just select my surface controller of my master points in my FFD. Modifier, and I just go into set array count to a number of objects, and then it also fits quite well off on this kind of surface. It just takes a little bit. This looks really well. We're probably a little bit surprised when we use really simple shapes like this orthogonal letter F, and we just use these because there's still some things we can now learn about Para3D, and especially these things related to smoothing. So what I do right now, I just selected both surface controller. I just select my letter F, and I just go into auto update. And this is what it looks like. It doesn't really fit in all directions to my surface, and also when I choose the other one with a little bit more like a higher subdivision, I will just choose this one, and I go into auto update. Let's see if this looks differently. Oh, it has the same thing, like it doesn't go around the corners and other little things. So let's start from scratch. I will just delete my Para3D. I can just say right mouse click, delete, and it just asks me if I want to keep my nodes in my scene. No, I don't want this. I say no, and then it deletes all my nodes, also my controllers. I can just delete, right mouse click, and we start from scratch. Not really from scratch, because you probably already watched my second video, and we just start with the same surfaces. We have this surface built on spline lines. We have these panel object, which we set together, and this is something you should repeat from my second video, basic knowledge of surface controller, and this is where we start right now. Okay, right mouse click, we go into create parametric array. Always just do it, use 10 by 6. And go into create. I want to use FFD modifier. I don't have to use editable mesh in this example, so I just start my Para3D settings right now, and I can adjust. It's a lot of information. I just close it and make it a little bit smaller. I saw that there was one little controller for my old experiments. I can just delete this, and so we start right now. Drag and drop for my transform. It's always important that you attach it first, and then I go into pick objects. I open my FFD modifier, right mouse click my master point. I select all, and drag and drop, and add my surface controller. This terms like always as an instance, and choose my pick objects again. And just because they all end up on one point, I need this sub-object controller, and I just select my surface controller again, and on UVW offsets I just add my sub-object controller. And if I now update my controllers, then it already looks really well. And one thing that's interesting to look at, if you have this reorder the transformations in parametric array, then you can see the order of how I attached my functions and controllers, and this is probably good to know that it already starts calculating in this order, so you can change the order of these internal calculation of my program. In this terms it doesn't make sense, but it's probably good to know that this has an impact on my Power 3D. Okay, what we also do is just quickly we give this whole thing a little bit more of dimensions in my W direction, my Z direction, and so here we go. Okay, what we want to look at is my smoothing options in Power 3D, these smooth in U and V direction. And with this kind of surface, if we just play a little bit around with this, it doesn't do much. I just increase it and go to 5. You can see it does a little bit of something, but it's probably not the perfect shape to explain what's going on. And it is like this, that most of the surfaces are probably freeform surfaces, but it's really good to look at this with a really simple surface, and we just start with a really simple cube and work with the cubes in terms of surface cladding. Okay, I close my windows, I go into my top view and just zoom to my scene. These are my objects, and I will just draw a really simple cube. I will look at this also in my front view. This is my cube. Make it a little bit higher. Then we just put an edit poly modifier on top, and we just delete the top and the bottom as these two surfaces. So we have a really simple shape like this. And I go again and select my power. I just choose one node, and I can just say select corresponding P array objects, and my Power 3D is opening again. I just choose my two surfaces and then select my basic cube. Here we go. And I will go into update array. I just press this button again. Sometimes this happens. I told you about this order. Oh, I made a mistake. This thing definitely has to go to the top. So you already had a good example that this has a big impact because I changed it beforehand. So that's also why it looked a little bit weird at the beginning. And this is what it looks right now. A little bit of an unexpected result. We just go into isolate selection to see this a little bit better. And what I do next, we just play a little bit around with these functions in my surface controller, these kind of smoothing functions. I have to select only my surface controller and master mode. And you have this smooth in U direction and smooth in V direction. If you first go into and select both times these number 2, and I will just tell you what this actually does. It already looks a little bit better. And when we look at my cube, my box actually, I just move it a little bit to this side, then we can see that it has 4 corners, and in each corner there is one edge. So what the program wants to do is, and this is what this smoothing means, it just tries to smooth between 2 vertices. One issue we already have to solve, because if we see our array count in 1 dimension, which is important, we have 10 items in the first direction, and we know that my surface only has 4 sides. So it has to be something which we can divide by 4. So it could be that we choose, for example, 4 items, already works really well, or we just choose 8 items, or we just choose 12 items. This is all possible, but it can't be something like 13. Then we already doesn't go on the corner. I think that's quite easy to understand. You can also just go again into this set array count to number of objects, and just press again and update, and then you have 4 by 1. That's a little bit little, but yeah, this just as one example. Okay, I go again into 12, and what we wanted to look at is these kind of settings. 2, 3, 4, 5, 6 in U and V direction stands for the amount of vertices Planarity uses for smoothing, means produces interpolated curves between these kind of vertices. So if I, for example, now instead of 2 choose 4, and I go into update, then you can just see that it tries to make a smooth curve around my whole object, because it uses 4 points to bring these things in order as a smoothing. Okay, we choose this surface again. I go into my box, and we just change a little bit the settings here. Height segment actually I don't need. We want to change the width and the height, and then I go into a polygon. Just delete this again. I just add another edit poly on top, and I will just delete these kind of polygons. So the topology now looks slightly different, and we just see what it does to my surface cladding. I just choose both surface controllers and just go here and choose my new box, and I auto update, and this is what it looks like, slightly different. And here the same thing. If I go into smooth and 2 by 2 and I auto update, then it looks pretty well. It also looks pretty well if I use 3 actually, and then we can just see that with 4 it already tries to make it round. It just works with 3, just because we can just have a look at this, because we have 3 vertex points on one line, so it doesn't make any difference if I choose 2 or 3, just in terms of the topology. So there's already a difference, and so on. If I go and choose 4, then it also looks different like this. And for example, if I just go here and move my sorry, I want to choose this kind of surface, and I move my vertex points a little bit. Just go into the top view to do this properly. I just move it like this, and I then go again and update my array. Oh, I have to select my my shape again, and I update. Then we can see what it actually does. It tries to smooth it like this, and we select again my number 3, and we just have a look. Now it's a little bit like a little house, and I just select 4 vertex points, and then we can just see that it tries to make it nice and round around this one. And if I just change my items, I just go to 24, then we can just see what it looks like with this kind of setting. So if you have an orthogonal shape, for example, like a letter, like this letter F, and I just extrude this with my extrude modifier a little bit. I put one edit poly on top. I will just delete my top and my bottom, otherwise I couldn't use it in a 2-dimensional array actually. And then again I just pick my array. Then I can select this surface, and you see it's much smaller, but this doesn't make any difference. And it looks actually like this, and I go again into my smooth in U direction. and it still doesn't look good. We learned why OD white is like this, because if you count the sides of the letter F, you count 10. If I go into my settings, you can see it's 24, so it has to be I have to be able to divide it by 10. If I just change it to 20 instead of 24, then I think it will already look better. It's still calculating. Okay, it already looks much better. What is probably a little bit too much right now is my thickness in my object. I just go and change this to 1 centimeter, and then we see that it works pretty well. And here the same thing. If I just change my smoothing to 4, then you can see that it already starts to smooth my whole objects in this term in U direction. I already showed it in my video panel surface. When you try to change the topology of a surface, it can sometimes be that it causes trouble. I just go into subdivision and into my tessellate settings, and I just change the topology like this, and I want to choose this kind of surface. Actually, I expect an error right now, and let's see what's going on. I just takes a second. Okay, parametric array surface controller invalid geometry. The geometry actually looks pretty well. It already shows that there's something wrong here, and it looks good, but there's one thing. Sometimes 3D Studio is not really clean. Some things don't work so well. So what I always do when something like this happens, I go into vertex, I select all vertex points, I go in my edit poly seconds to the function break. Let's see where I find it under edit vertices. I select all of them. Before we had 60 vertices, and if I go to break and select all again, then I have 160 vertices. And if I then weld them together again and select all of them, then I'm back at 60. Looks a little bit stupid, but this normally does something. When I now go again in my Power 3D settings, just open it again. That's a little bit annoying. I think in newer version we don't have this anymore. Then I just go and select both controllers, and I choose my object, and I go into auto update, and here we go. It works properly. So if you have problems with your geometry, just do this, break the vertices and weld them together, and most of the time then it works pretty well. The next thing we want to look at is these spacing options in Power 3D. I just used my surface again, basic surface, and my array count is now 20 by 10. And we just look at the spacing options right now here in my surface controller of my FFD box master control points. So we have this fixed number of surfaces in U and V direction, means 20 objects in my first dimensions are fixed and 10 objects in my second dimension are fixed. But on top I can also say that I want to fix the distance. If I go to distance and just go into array, then the whole thing looks probably a little bit weird, because in my first dimension all objects now have a length of 1 centimeters in my U direction. If I change this, probably I go and change it to 10 centimeters and click on auto update, we just see what's happening. The objects become much bigger, still not the full length because my whole surface is a little bit longer. So if I deselect the fixed numbers of items in my u direction, it just tries to make this fit. And we just see it goes until the end. It also moves them a little bit. We talk about this later. So it just looks like this, but the amount of items is still not enough to satisfy the whole surface. I just select fixed numbers again. And what we can do if you want to do this, that all my whole surface is covered again, then I just have to select my FFD surface modifier and just say next step, set array count to number of objects, and then it just fills my surface. Okay, so what did I do? I just entered number 10, the distance, and I will just select one of these objects. I just go in isolate selection, and I will just measure them. 3 dimensions set as snap toggle. I just choose vertex points, and then I go here under my helpers and choose my tape, and so I can just measure this, and it just says 9.24 centimeters. That's not exactly 10 centimeters what I actually entered, and there's a reason for this, because it's obvious. All these surfaces, all these panel objects fit together. There is no gap, and just because my whole surface is not straight, it's impossible that all elements have 10 centimeters in terms of my distance of u direction. But you can optimize it. You can also make a decision which kind of objects should be 10 centimeters, and so the others will interpolate a little bit. So what you can do is you can use this measuring belts, and that's a really nice function. If I just switch this on, you can see that position 50 is the middle of my surface, and depends on where you move this measuring belt. It just tells you at this position it has to be the distance of 10 centimeters. We also have this in v direction, and this is something to understand, but it's also quite obvious. The v direction defines this distance, so if I just choose my v direction and I move it a little bit, and then go into update, then we just see that the whole thing is changed slightly, and I just go into auto update, and then we can see this even faster. So if I again choose my measuring belt, here we go, we can just see that when I enter a different value, I just do it with my keyboard right now, I just go into 70, then we just see that the whole thing is slightly moving. I deselect auto update again, and we just have a look at my object, which is now, let's move this up again, just right now under these measuring belt in my v direction. It's actually this one. I isolate this again, and I measure this with my tape measure, and you can see this is already really close to my 10 centimeters. And if I just move my measuring belt again, for example, here I just move it up and I update it, then we can say it moved completely somewhere else. And I just measure this, and so you can't see this properly, and it just tells me that it's 11 centimeters, so it's just definitely a completely different kind of position. And if I move it down again, it just fits on it, and then it will change the position again. And if I measure it again, then we can see that it already fits much better. It's 10.02. That's already pretty close. Just to show it to you, if I change this one, this means my measuring belt in my u direction, and I update it, it doesn't have any impact on my on my panel object. So this is just something you have to get used to, but it's also a pretty clear thing in a geometric way that the redirection is responsible for this distance. You can obviously do the same with your redirection. If I go to redirection and update, then we already expect it can't look good because the dimensions are just 1 centimeter. If I also go to 10 centimeters and I update, then it already looks much better. And if I just move my measuring belts, okay, what's happening right now? I just don't have enough objects here, so I could just choose my set array counter number of objects. This is something I don't want to do right now. So if I move my measuring belts to this position and this one to this position and I update my array, then I would expect, okay, I have to move this even a little bit further further up like this. Then I would expect that these objects here fit pretty well. I just isolate them and I measure them again with my tape. So I just measure this direction. That's already really close to 10 centimeters, and I measure it in this direction. It's also really close. So I think we got a feeling for this measuring belts. If I, for example, measure this one, just to show you that they're definitely different, and measure here this length, then you can see that this is 23 centimeters, so there's a huge difference. So you have to make your measuring belts fit at the point where you want to have it the right size. There's an alternative and also a different thing you can try, which is also quite interesting. Okay, I just deselect my fixed distance in redirection. This is what it looks right now. And if I just say I don't want to have fixed numbers in my U direction and I update it, then we see something, and we just turn my scene a little bit to see it better at the corners. So we see that they don't fit so well together anymore. They're not really on one line, because for one reason, all these objects, doesn't matter which kind of objects I choose, I just choose this one and I will measure this. They're all more or less slightly, could be 1 millimeter difference, just because they're still distorted. They're all centimeters, all 10 centimeters in terms of U direction. And first, it's a really interesting effect because you can have this bonding structure. But what you should probably do is, I don't want to have these things at my corners. So what you can do is you can just say, I want to trim my array and my U direction. And I just switch on trim, and we just see what it does. It just cuts them off. And if I now go again into set array count to number of polygons, it fills my whole surface, and we have full control with this kind of settings in terms of spacing. We have full control over my surface paneling. We can define the U and the V, the width, the length, and the height, and we can also see how many objects we want to have in U and V direction. So it's a really pretty cool tool to use. It is like this, that you minimum have to choose one of these options, otherwise you will get an error. So I just go back to my fixed numbers and go to auto update, and I just reduce them a little bit, so I have again like 20 objects in my first dimension, and then probably 12 objects or 14 objects in my second dimension. Okay, and the rest of this video, I'll reduce it, it's too much for me right now. The rest of the video is probably like being in progress, because there's one really interesting thing in Power 3D, and it's also really important for architecture and design. This is Planarity, and if you look at these objects, my panel objects, probably even more extreme, let me see, probably this guy, then you can see that this thing is not really planar. It's distorted, and so you can't probably produce this in an easy way with a laser cutter or things like this. So there's one thing you can do in Power 3D, and I can also imagine that I still have to practice a little bit, so this video is just a starting point. I will update my video starting from here. There's one interesting function, and this is this surface optimization. I'll just show you quickly what it does. We first have this optimize edge length, so we can optimize the length of these kind of objects. So what I do right now, I just select this and update it, and we can see that it has an impact on my geometry. I just hide my surface so we can see this a little bit better. So it optimizes the length and the width of my object. And the next thing, I can also change the iterations. If I go to 1, then I'm quite close to my basic settings again. So this is definitely worth looking at. The next thing is this optimize planarity, and if we choose this, then this also has an impact on my basic geometry. This means if I want to optimize the planarity, then it has to recalculate also the relation to my basic surface object. And if I update this and the setting is quite complex, then we see that it changes my shape quite a lot. But the advantage of this is that all my objects are now already more planar. So I will have a look at this, for example, and it looks better. But there are many options to play with to optimize this. I'm still not the expert on this, so I will practice a little bit and try to figure this out. Anyhow, really interesting, and thanks for watching.